Welcome back to my rubber heart. Today we are talking about something that's often overlooked, but absolutely critical in rubber compounding: tackifiers. These are the materials that give rubber its stickiness, its ability to bond to itself or to other surfaces during processing or in finished products. Now, tack isn't just about something feeling sticky to the touch. It's a carefully engineered property, essential in applications from tire building to adhesive tapes to weather seals. The science behind tackifiers is much deeper than most people realize, and today we are going to get into exactly how they work, how they interact with rubber, and why they are so important in practical rubber applications. Let's start with what a tackifier actually is. Tackifiers are usually low molecular weight resins, often between 500 and 5000 gram per mole, and they are designed to alter the viscoelastic properties of a rubber compound. What they do is modify how the rubber flows and recover under stress. In technical terms, tackifiers adjust the storage modulus, or G prime, and the loss modulus, G double prime, of the compound, especially in the frequency and temperature ranges relevant to adhesion. By increasing the loss modulus relative to the storage modulus in this window, tackifiers raise the energy dissipation and enable better wetting of the substrate, essentially making the rubber more willing to stick. But tack isn't just about flow. There's also a time element. When two rubber layers are pressed together, tackifiers allow the molecule at the surface to mobilize quickly and form temporary interpenetrating networks. Not full covalent bonds, but enough to form a physical connection that holds the layers together during processing. This is crucial in tire manufacturing, for example. Before vulcanization, the different plies of rubber need to adhere well enough to stay aligned during calendering, rolling, or curing, and tackifiers make that possible. Now, let's talk about what's happening on a molecular level. Tackifiers don't form chemical bonds with the polymer chains, but they do interact physically. They solvate the surface layers of the rubber, reducing its modulus and increasing surface energy, which in turn enhances adhesion. The best tackifiers are those that are compatible with the polymer matrix, meaning their solubility parameters are close to those of the base rubber. For non-polar rubbers like natural rubber or polybutadiene, hydrocarbon resins, especially C5 and C9 petroleum derivative resins, are often used. For more polar systems like nitrile rubber, acrylic, or phenolic tackifiers might be more appropriate. But a tackifier on its own doesn't create tack. It's part of a broader formulation strategy. Plasticizers or processing oils are often included to keep the compound soft and allow better migration of the tackifiers to the surface. In some systems, resin-oil ratios are carefully balanced to tune the tack to a very specific application. If you have too much oil, you reduce cohesive strength. If you have too little, the tackifier can do its job because the matrix is too stiff. Antioxidants are also important because tackifiers are often based on unsaturated systems that can oxidize or degrade over time. In pressure-sensitive adhesives, stabilizers are often added specifically to protect the resin phase from UV and oxygen. One interesting aspect of tackifier behavior is that it's very temperature sensitive. Most tackifiers raise the glass transition temperature, or TG, of the formulation. That means at room temperature, the rubber is soft enough to be tacky, but once it's cured or cooled below TG, the tack disappears and the final product becomes more solid or rigid. This is exploited in hot melt rubber adhesives, where tackifiers allow the material to be molten and sticky during application, then set quickly as it cools. The choice of tackifier and how it's used really depends on the end use. In tire manufacturing, tackifiers are used to ensure the green rubber layers stick together before vulcanization. Without tack, those layers could delaminate during shaping or curing, leading to defects. In adhesive applications, particularly pressure-sensitive adhesives like tapes, labels, and protective films, Tackifiers are absolutely central to the performance. These systems rely on a rubber resin oil matrix that remains permanently tacky but doesn't flow under load. You also see tackifiers used in rubber to metal bonding systems, where a layer of rubber has to bond well to a primed metal substrate during vulcanization, and the right tack level can improve wetting and anchorage. Even in automotive weather strips, tackifiers come to play. When co-extruding or bonding different rubber profiles, the pre-cured surface need enough green tack to maintain shape integrity and alignment before they are fully bonded. The same goes for diaphragm laminates or multi-layer rubber hoses, where consistent adhesion across layers ensures the mechanical integrity and the structure under pressure. So in the end, tackifiers are far more than simple adhesives. They are strategic tools for controlling how rubber behaves during processing and the early stages of adhesion. They influence flow, surface interaction, wetting, and energy dissipation. And while they don't contribute to the final crosslink structure directly, their role in pre-vulcanization stage is critical to the success of the finished product. Thanks for tuning into my rubber heart. If you enjoyed digging into the science behind what makes rubber sticky, don't forget to like and subscribe. If you've got questions about tackifiers in your own compounds or want help troubleshooting poor green tag, drop a comment below. Let's get sticky with it, and see you next time.